So the question is how decorators abstract boilerplate ML. Okay, so we will keep we will ask this question to AI. I think we have already asked this question. आणि आता आपण बघूयात की बॉयलर प्लेट ओके आपण हा क्वेश्चन decorators in the machine learning are decorators in machine learning are powerful because they provide non-intrusive way to inject repetitive operational code the boilerplate into functions across the pipeline. आता what is boilerplate टाकूया आपण इथे. Boilerplate is a programming term for the section of the code that are repeated in multiple places with little or no variation, or the code that must be included in nearly every program or function to make it work even if it does not perform the core unit action. In simple terms, it's a code that you have to write over and over again that does not add unique value to the specific function you are working on, but is necessary for the operational reasons. Okay, common examples of boilerplate are every file often needs same import OS, import logging, etc. Error handling, try, except, final, setup tear downs. Okay, boilerplate in the context ML data science, model.fit, model.fill.na, etc. ओके, तर आता इथं काय त्यांनी म्हणलंय बॉयलर प्लेटचं decorators in the boilerplate into the function across the pipeline. Instead of manually writing the same logging and timing logic inside the dozens of different functions, we write the logic once in the decorator function and apply it with @ symbol. This makes the core machine learning code clean and focused purely on the modeling or data transformation tasks at the end. म्हणजे काय डेकोरेटर्स मशीन लर्निंगमधले पॉवरफुल आहेत कारण की ते नॉन इंट्रेसिव्ह वे टू इंजेक्ट रिपिटेटिव्ह ऑपरेशनल कोड नॉन इंट्रेसिव्ह वे हे करतात प्रोव्हाइड करतात to inject a repetitive operational code, the boilerplate into the functions across the pipeline. तर इन्स्टेड ऑफ मॅन्युअली रायटिंग प्रत्येक वेळेस मॅन्युअली सेम लॉगिंग और टायमिंग लॉजिक लिहिण्यापेक्षा डझन्स ऑफ डिफरंट फंक्शन्समध्ये सेम टायमिंग आणि लॉगिंग लॉजिक लिहिण्यापेक्षा वी राईट द लॉजिक वन्स अँड इन द डेकोरेटर. आपण एकदाच डेकोरेटरमध्ये लॉजिक लिहायचं अँड फंक्शन अँड अप्लाय इट विथ @ सिम्बॉल आणि प्रत्येक वेळेस त्या @ सिम्बॉलने अप्लाय करायचं. दिस कीप्स द कोर मशीन लर्निंग कोड क्लीन and focused purely on the modeling or data transformation tasks at hand. Logging and experiment tracking. आता machine learning operations like ML flow, weights and biases, MLOps platform like ML flow, weights and biases require every single step of workflow to log metrics, parameters and artifacts to central server. Manually managing the start and end these tracking runs in every function is tedious, error prone. How decorators help? आता track experiment, train model data hyperparameters. This is a clean core machine learning logic only. Model, some training function, data hyperparameters, return model. Okay, @ track experiment, decorator handles all the setup and tear down code, abstracting away the communication with the logging server. Timing and performance monitoring. Machine learning pipelines frequently involve functions that run for a long time, such as training large models or pre-processing massive data sets. Measuring the duration of these operations is crucial. Measuring the durations of these operations is crucial for optimization, but adds the repetitive timing code for every function. How decorators helps? Simple @timer decorator automatically logs how long each step takes to complete. Okay, आणि त्याच्यानंतर catching and memorization. Data scientists often rerun the same data pre-processing steps multiple times across the different experiments, which wastes a significant of computational resources. How decorators help? The @catch decorator can memorize the results of the functions if the function is called again and exact same inputs. The decorator intercepts the call immediately return the previously stored results, entirely bypassing the expensive recomputations. Summary: by wrapping the functions with the decorators, ML developers can adhere to do not repeat yourself principle. They keep their core machine learning code focused strictly on the specific tasks: training, prediction, and data cleaning, while decorators handle the common, repetitive, and often complex operational aspects of the modern machine learning systems. Okay. Then the next question is, how do decorators helps the data flow? How do decorators helps the data flow? आता हा पण क्वेश्चन आपण तिकडेच जाऊन विचारूया जेनेआयला, कारण त्याचं एक्सप्लेनेशन खूपच चांगलं वाटतंय आपल्याला. Okay, तर decorators, how decorators help with the data flow? Decorators can enhance the management efficiency of data processing within the individual function. Although they do not control the direct path data takes between the functions, they improve how the data is handled at a specific processing points by managing the cross-cutting concerns. म्हणजे काय, तर आपण आता इकडे बघू. The video is primarily how decorators modify or extend the how decorators help the data flow. How decorators modify and extend the behavior of the functions without explicitly changing the code. While the video doesn't directly use the term data flow, the functionalities of the decorator it describes is indirectly influence how data is processed or managed. आता तरी आपल्याला म्हणावं तसं एक्सप्लेनेशन त्याच्याने मिळालं नाही. हाऊ डेकोरेटर्स, आपण हा क्वेश्चन टाकूया, आन्सर नको टाकायला. इन जनरल तो काय सांगताय बघू. नॉट ऑन द users previous context notes that decorators do not directly control the flow of data between the functions in the way an orchestration tool might. Instead of they optimize the monitor and how to process within the specific functions. Catching and optimization, preventing the redundant flow mechanism. A decorator can implement the catching or memoization impact on the data flow. If the same input data is passed to the decorated function multiple times, the decorator intercepts the call, instantly returns the previously stored results, and prevents the raw data from having reprocessed through the heavy computational logic again. हेवी कॉम्प्युटेशनल लॉजिक परत प्रोसेस करण्यापासून थांबवतो. दिस अवॉइड्स रिडंडंट डेटा मुवमेंट अँड प्री प्रोसेसिंग अँड प्रोसेसिंग टाईम. रिडंडंट डेटा मुवमेंट आणि प्रोसेसिंग टाईम ह्याच्यामुळं थांबलं अवॉइड केलं जातं. व्हॅलिडेशन अँड ट्रान्सफॉर्मेशन, एन्श्युरिंग द करेक्ट फ्लो. Input validation. A decorator can act as a gatekeepers or modifiers right as the data enters or leaves the function, ensuring the data integrity and throughout the pipeline. Input validation. A decorator can check if an incoming data frame has the correct schema, column types, or shape before the function attempts to process it. This stops the bad data from flowing further down the pipeline and causing cryptic errors later on. Data transformation. The decorator could ensure the standard transformation is applied to input data consistently across the various functions, ensuring all the text input is a lowercase or normalized before processing, monitoring the data processing, providing the metadata flow, logging the data shapes and types. The decorator might automatically log the shape of the data before and after the transformation function runs. This helps the data scientists track how the data is changing and identify where the dimensions might be dropping unexpectedly. म्हणजे काय, a decorator might automatically log the shape of the data before and after transformation function runs. This helps the data scientists track how the data is changing and identify where the dimensions might be dropping unexpectedly. Timing performance. By timing function, the decorators helps to identify the bottlenecks in the data flow pipeline. Data flow pipeline मधले bottlenecks find out करायला help करतं आणि showing the which processing steps are slowing everything down, आणि कुठली प्रोसेसिंगची स्टेप सगळं स्लो करतीये ते आयडेंटिफाय करायला मदत करतं. ओके, तर डेटा फ्लोला डेकोरेटर्स कसं हेल्प करतात ते कळालं आता. व्हाय रेंज फंक्शन इन पायथॉन 3 इज बेस्ट. The Python 3 is best of both worlds because it behaves like a iterator generator. Here is why it's considered to be superior. Low memory usage. It has a constant memory usage, O of 1. तो लो मेमरी यूज करतो कारण O of 1. This is because it only stores starts, stop and step value, yielding number on demand similar to the X range, आणि number फक्त on demand yield करतो similar to the X range in Python 2. Efficient time complexity. It initializes the time complexity is also O1. O of 1. Memory usage is O of 1. Initialization time complexity is also O of 1 and near instant and regardless the size of the range. Standard practice. It's the recommended and standard practice for all the ranges in the Python 3. How do the decorators abstract MLOps? Decorator abstract MLOps by providing clean and non-intrusive way to inject the repetitive cross-cutting concerns. I think आत्ताच आपण त्याचा आन्सर बघितलं, कॅचिंग आणि मेमोरायझेशन आहे. आणि त्याच्यानंतर काय आहे, हाऊ द डेकोरेटर्स ॲब्स्ट्रॅक्ट्स MLOs, ह्याचं पण आन्सर बघितलं. हाऊ डू init and call differ. ओके, हाऊ डू init and call differ. Init आणि call functions in the Python classes are as follows. Init हे काय तर कन्स्ट्रक्टर मेथड आहे. इट इज कॉल्ड व्हेन द इन्स्टन्स ऑफ द क्लास इज क्रिएटेड. जेव्हा क्लासचा इन्स्टन्स क्रिएट केलेला असतो तेव्हा हे कॉल केलं जातं. आणि कॉल इज अलाउज टू द इन्स्टन्स ऑफ द क्लास टू बी कॉल्ड ॲज इफ इट वेअर द फंक्शन. ते फंक्शन असल्यासारखं त्याला कॉल केलं जातं. It is often used in the framework like PyTorch, TensorFlow, custom layers and or scikit-learn for custom transformers. ओके, तर init हे काय तर कन्स्ट्रक्टर आहे आणि जेव्हा क्लासचा इन्स्टन्स क्रिएट केला जातो तेव्हा init कॉल केलं जातं. आणि इज अलाउज द इन्स्टन्स ऑफ द क्लास टू बी कॉल्ड ॲज इफ इट वेअर द फंक्शन. तर कॉल मेथड आहे ना ती अलाउज द instance of the method to be called when. Why the generators preferred for the large data. Generators are preferred for the large data because they calculate the values lazily. This means that they produce the sequence of the result one at a time. ते एका वेळेस एकच रिझल्ट प्रोड्यूस करतात, pausing the execution and saving their state until the next item is requested. रिझल्ट पॉज करतात until the next item रिक्वेस्ट करत नाही तोपर्यंत. This lazy evaluation allows them to consume minimal memory. त्याच्यामुळे त्यांची मिनिमम मेमरी कंझ्युम होती, मेकिंग देम आयडियल फॉर द सिच्युएशन्स वेअर लोडिंग ॲट द एंटायर डेटा सेट इन द मेमरी इज इम्पॉसिबल. त्याच्यामुळे ते आयडियल होतात जिथं लोडिंग एंटायर डेटा सेट इन द मेमरी इम्पॉसिबल असतं तेव्हा. Such a reading message and in the contrast the comprehensive, it is least comprehensive complete list in the memory immediately, which is problematic for very large data sets. Okay.